Hi, in this video we're trying to get an idea of what the SHM equation is like. Simply put, the SHM equation may be represented in this way, where x is equal to a sin omega t plus phi, or if it's vertical you could write the same thing for y, where y is equal to a sin omega t plus phi. But what does this equation represent? If you look at the motion, this is what it looks like.
This would be y is equal to a sin omega t plus phi, the vertical SHM. And this would be x is equal to a sin omega t plus phi, which is the horizontal SHM.
Now let's get to the first part of this equation, which is the x or the y. Let's say x. What x is it? Suppose your SHM is going on in this particular span. Is x just the x coordinate, or is it something else? Suppose your origin were here, then is the x coordinate of the bob the x in the equation? In that case, this length will have to be x, and that is not true. In fact, this x has a very specific origin associated with it, which is the mean of the SHM. So if you took this as the y-axis, this dotted line, then the displacement from the mean, which is this length, would become the displacement in the equation. So it looks something like this.
The green arrow shows the displacement. On the right side it is positive, and on the left side you see it is negative.
Moving on, what is the next part of the equation? That would be the A, which you might be aware is called the amplitude. And what does this indicate? So if your SHM is going on this way and this is the mean, then the maximum displacement by the bob would be the amplitude. And this makes sense because when you look at x is equal to a sine of something, what is the maximum value of a sine? Plus 1. So x would be maximum when the sine is maximum. In that case, x is just a. And when the sine is minimum, that is when it becomes say minus 1, in that case x becomes minus a. And this makes sense in that the displacement from the mean would be maximum here, and it is also maximum in the other direction here, where it becomes minus a. So this is what the a part in the equation signifies. And now we come to the slightly more interesting, curious part, which is the sine omega t plus phi. What does the sign indicate? For a while, let's just look at a situation where phi is 0. So let's take, say, y is equal to a sine omega t. What happens here? For this, let us draw the sine curve. Let us see what a sine omega t looks like. If this were the time axis and this is the y-axis, then a sine omega t, y is equal to a sine omega t, would be something like this, which is the sine curve. So you have a bob that starts here, and as time is progressing in this way, this bob goes like this and comes down and goes further this way and goes up and so on. It would look something like this.
So the green bob there is time going at the rate of time, and now you see how the red bob is y is equal to a sin omega t, which is the SHM as well.
Here's where we come to one of the key misconceptions in SHM. Suppose an SHM is going on this way, about this mean, and it takes say 4 seconds to reach the extreme from the mean. So it makes this much displacement in say 4 seconds. Now the question is, if I asked you at 2 seconds where will it be, and say your answer is it will be exactly in between, that is a by 2, then that would be wrong, because this is not moving with linear speed. The body's velocity, given the fact that x is equal to a sine omega t, then dx by dt, which is the velocity, is a omega cos omega t. The velocity itself is changing with time. So you do not have a linear situation where it takes 4 seconds to cross a and therefore 2 seconds to cross a by 2. So what is actually happening? Your x is changing sinusoidally. So if you want the x to be at a by 2 at any point of time, then that would be a sine omega t. The a and a cancels off, so half is equal to sine omega t, which means omega t has to be pi by 6 or 5 pi by 6. Now let's consider the case of pi by 6 itself. So if it takes 4 seconds in order to go to the end a, so a is equal to a sine omega into 4. So 4 omega becomes pi by 2, and that makes our omega is pi by 8. So at what time does it become pi by 6? That would be pi by 8 into t is equal to pi by 6, and this gives us t is 4 by 3 seconds. So it is at 4 by 3 seconds that the bob is going to execute a displacement of a by 2. So here we've observed that the angle in the sine is what really matters, and that is given the name phase. And this portion, the omega t plus phi, clearly tells us what part of the SHM the bob is in. So if the body is at the mean, the phase is 0, because a sine 0 is 0. And when it goes to one extreme, it is at a phase pi by 2. And when it is returning from there to the mean, this phase was pi by 2, but now this phase is pi. So you see that the same displacement could occur twice in one cycle. But here the phase is different, here the phase is different, and that corresponds to the distinct parts of the SHM, where here the body was moving in this direction and here it is moving in this direction. The velocity is different, although the displacement might be same. And from the pi phase, the bob could move to the next extreme, which is at a phase 3 pi by 2. This is the minus a. And finally from there, you go back to the mean, which is now a phase of 2 pi. And from 2 pi, just like sine, the motion executes the same beats again. And this keeps going on forever. So what exactly does this phase part indicate? We've just seen something intuitive, but it would be better if we could probably see a more physically intuitive version of it. And for that, let us take a circle and let a certain bob start from here and go in uniform circular motion with an angular velocity omega. So when it reaches a particular point here in time t, what would this angle be? This would be omega t. And then if the radius of this particular circle is a, what is this height? And that height, as you probably observed, is a sine omega t, which is incidentally our SHM. So what's going on here? If I mapped projection of this bob on the y-axis, then you will see that the bob is undergoing an SHM which goes as y is equal to a sine omega t.
Which looks like this. The y projection is a sine omega t, which is an SHM.
So that's what the SHM sinusoid indicates, and that's what the phase indicates. So if you look at it in terms of the circle, then quadrant 1 is when you go from the mean to one extreme. Quadrant 2 is when you go from that extreme back to the mean. And quadrant 3 is when you go from the mean to the other extreme. And quadrant 4 is when you're back from the extreme to the mean. And now finally, what is the phi business? Say we started our circular motion not at the mean. Say we started it when it is already covered a certain angle phi. So the bob is at an angle phi. In this case, on the SHM, the body is at y is equal to a sine phi. So this is when we are starting our clock, and therefore now if the bob is going to go with an angular velocity omega, after a time t, this angle is omega t, but for the projection sake, here y is going to be a sine of the whole angle, which is phi plus omega t. So what the phi indicates, the phase constant indicates, is we started our clock when a phase of phi has already been executed. The body is away from the mean at a distance of a sine phi.
So that's what we see here. There is the phase of phi already. And now the circular motion begins, causing an SHM of y is equal to a sine omega t plus phi.
So this is what the entire equation indicates. X is equal to a sine omega t plus phi is a horizontal SHM, and y is equal to a sine omega t plus phi would be a vertical SHM. If you have to look at them both together, you see the y projection is going to be y is equal to a sine omega t, but the x projection also is going to be an SHM, and this one is going to be x is equal to a cos omega t. What this means is there is a phase difference of pi by 2 between this SHM and this SHM, and clearly, as you can see, the y is reaching its extreme when the x is reaching its mean, and the x is reaching its extreme when the y is reaching its mean, which makes x is equal to a sine omega t plus pi by 2. That means there is a phase difference of pi by 2 between the x and the y. So that explains the SHM equation. Thank you.